All right, ladies and gentlemen, what I'd like to say real quick is check in your guys' challenge questions. Okay. Obviously, you guys already did your challenge questions. It should be completed in the Google Doc. The most important part right now is that you actually have your notes in front of you, and then you could check your answers with me. Therefore, you either got it right and you're like, I got it right. I know how to do this. Or you didn't get it right, but you can see the difference of how I came up with my answer and how you came up with your answer. So let's get to work. Oops. All right, ladies and gentlemen, we do have a decimal. The question is this decimal fine, or do we have to come up with a problem without the decimal? Well, it's not in the divisor, so this decimal is fine and dandy. All you have to do is make sure it floats right above where it is right now. How many fives going to 2? None. How many fives going to 27, though? 5. 5, 10, 15, 20, 25. 5. What's left over? 2's left over. We already took care of the decimal, so now we could bring down the next digit. How many 5's going to 28? Again, 5. What's left over? Well, there's 3 left over after you took away 5 groups. How many 5's going to 35? 7. Is there anything left over? Nope. B. 81 times 3.5. Uh-oh, we have a decimal. Decimal. What's the rule of decimals with multiplying? Oh, yeah, ignore it. Use whatever method. You are the best at double-digit multiplication. I like lattice method. 3 times 1 is 3. 8 times 3 is 24. 8 times 5 is 40. 5 times 1 is 5. I got to make it double digit. Done with the outside numbers. 5 falls down. 3 falls down. 4 and 4 hit each other. They turn into 8. And then the 2 falls down. Now I have 1 decimal to deal with. So my answer has to have 1 decimal number. Answer's 283 and 5/10. Let's go to C. Trying to build from what we learned yesterday. The very first thing and remember, this does not mean you multiply before you divide. It just means multiplication and division are equal. So first thing that we want to do is in parentheses. 3 divided by 6, which is 3/6. What is 3/6? Now I'm going to rewrite it. What am I doing next? Eight times a half. Well, 8 times a half, remember how to multiply this? 8 turns into 8 over 1. Multiply across. It equals 8 halves. What is 8 halves? Well, how many? Remember, it takes 2 halves to make a whole. How many 2 halves are in 8? 4. Half of 8's 4. That makes sense. So now I only have these 2 left. Answer 60. And then last, we got this nasty challenge, though. This is a hard one, okay? It's okay if this is a hard one. You just have to break it into normal figures. The easiest way I could see to do that is if you cut it right here. Now this is 9, but we don't know this piece. But do we know this piece? Yeah, it's 2. And if this is a normal rectangle, that's 2. Oh, this is 2 as well. And if this whole thing is 5, this has to be 3. And if this is 3, 9 times 3 is 27. So the bottom has an area of 27. What about up here? Do we have enough? Yeah, 2 by 4. That has an area of 8 centimeters squared. And then what about this? 3 by 3. 9 centimeters squared. So now all I have to do, 27 plus 9 plus 8. That will give me my answer. 16, 17, 18, 19, 20, 21, 22, 23, 24. And remember, it's a 2-dimensional flat area and it's centimeters. So 44 squared centimeters, or centimeters squared. All right, that will do it for our challenge questions. Now, let's jump into our actual lesson. All right, let me get rid of this ink. So once again, we are working with the coordinate plane. Coordinate plane reminds me a whole lot of Battleship. So if you have some Battleship experience, this coordinate plane should be no problem for you. And even if you don't have Battleship experience, this coordinate plane should be no problem for you. So let's move on. Just really quick reviewing from yesterday. This is called the x-axis. It is horizontal. This is called your y-axis. It is vertical. The line of origin is this guy right here, 0, 0. It's where it all begins, 0, 0. And then when you plot something, say you plot 5, 1, it's always over and then up because it's x and then y. So you go over 5, up 1, and that's where you would plot this fake coordinate that I just made up. So today's lesson, Unit 7, Lesson 6, which is the final lesson in Unit 7. Today we're going to take it one step further. We're going to graph ordered pairs, but we're also going to see that ordered pairs can happen naturally in life in different patterns, and then we get to take those patterns and graph them. So let me throw myself over here. Let's get through some of this. I'm going to try to write this stuff down with my mouse, but it gets very, very tricky. So this has a rule. The rule is add 4. So x is on this side, y is on this side, and we are going to then fill out the table, and then we're going to fill out the coordinates, and then we're going to graph it. So complete the table, the add 4 table. All right, so the rules add 4. Let's complete the table. 1 plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7. 4 plus 4 is 8. And 5 plus 4 is 9. Hopefully you two are writing this in your book, right? And then going over here, we're going to take these x, y. And how do you know they're x, y? Well, it's because on this side, it's going to be our x because it is written Over here on the left, it is the variable that was there, and then you apply the rule to it to see where the y is. So here we have 2, 6, so we write down 2, 6. Here we have 3. When 3 goes in, 7 comes out. When 4 goes into the rule, 8 comes out of the rule. When 5 goes into the rule, 9 comes out of the rule. Now we got to plot this. First one is going to be 1, 5. And see how they don't have any label to them? Then they're not looking for a label. The only thing that they're looking for is for us to plot the coordinate. So that's all we have to do. Let me try to use this here. All right, so the first one was 1, 5. So 1 over 5 up. The next one is 2, 6. So 2 over 6 up. The next one is 3, 7. 3 over 7 up. I hope you're already starting to see the pattern. The next one is 4. 4 over 8 up. And then the last one is 5 over 9 up. And then usually, which I don't think they're telling us to do it here, okay, a lot of the times in order to see the pattern, they actually want us to show the line. So we would start here and we could connect them. And then also what you can do is you can predict all of the other answers if X is to change. And there you go. That's all you have to do. Should we jump into this one or wait for the live session? You know what? Let's do it. Let's jump into one more, and then we'll finish the rest of these during the live session. Suppose a shrub grows at the rate shown in the table below. Use the table to complete 4 and 5. Okay. So what's happening in a real world here? There is a shrub, which is like a bush, right? Like a mini tree or a bush. So it says when it's 0 years old, it has no height because it is 0 years old. It didn't even get planted yet. If that shrub is there for 1 year, it actually is 1 foot tall. If it's there for 2 years, it's 2 feet tall, 3 feet, 4 and 4 feet. You get it. So the first thing they want us to do is write the ordered pairs. So let's do it. If you guys want to pause and try to write the 5 ordered pairs yourself, that would be cool. Now it says graph the ordered pairs. Same thing. If you want to pause and try to graph it on your own, that would be great. So 0 over 0 up would be right here. 1 over 1 up would be right here. 2 over 2 up would be right here. 3 over 3 up would be right here. And then 4 over 4 up would be right here. What we can do with this one, if we're feeling lucky or crazy, we can now connect these and predict as the bush ages or the shrub ages, we can predict how tall it's going to be at whatever year it is. So it says, what does each axis of the graph represent? Well, what does the X represent? What's the first number represent? Age in years, right? And then what is the Y? Oops, you don't want my zoom. What does the Y represent? The Y represents the height of the shrub in feet. And then if you're ever to make your own, grid, oops, man, I'm messing this whole thing up. All right, you guys get it. I wanted to turn it to make it look a little prettier, but it is what it is. So the X-axis represents the age, and the y-axis represents the height. All right. What should we do here? Let's go with, because I'm staring at this pizza guy behind me, let's go with sunglasses. So if you watch today's lesson, you're going to be able to tell me, hey, the thing that you really referenced, sunglasses. All right, I'll see you guys at 10:30 for the live session. Nicely done. And then we'll finish off this lesson at 10:30.